students, this is Mehboob Ali, PGT Chemistry from Kendra Vidyalaya Byawar. In this video lesson, we will discuss about the laws of chemical combinations. This topic is in first chapter of class 11 chemistry, some basic concepts of chemistry. So let's start. So our first law of chemical combination is law of conservation of mass. This law was given by Antoine Lavoisier, and the statement of this law is matter can neither be created nor be destroyed in a chemical reaction. So this means that total mass of reactants before the reaction is also equal to the total mass of products. Okay, now our second law is law of definite proportions. This law was given by Joseph Proust, and the statement of this law is a given compound always contains exactly the same proportion of elements by weight. For example, Joseph Proust take 2 samples of cupric carbonate. One cupric carbonate he taken from the natural sample and another sample was synthetic. In the analysis of both of the sample, he was found that the percentage of copper, oxygen and carbon is same in both of the samples. It is 51.35 of percentage of copper in both of the samples. Similarly, oxygen and the percentage of carbon is also same. So this experiment proved that the percentage, or you can say the proportion of elements, is always same whatever its origin of the compound is. So these two laws you have already studied in class 9. Okay, now third law. The third law is law of multiple proportions. This law was given by Dalton. This is the statement of this law. If two elements can combine to form more than one compound, the masses of one element that combine with the fixed mass of other element are in the ratio of small whole numbers. See the example. Suppose there is a reaction between hydrogen and oxygen. It forms water. In this example, 2 gram hydrogen react with 16 gram of oxygen and forms 18 gram of water. In next example, the same two elements, hydrogen and oxygen, also combine and form hydrogen peroxide. But in this example, hydrogen is also 2 gram, but oxygen that react with the fixed mass of hydrogen, that is 2 gram, is 32 gram. It forms 34 gram hydrogen peroxide. So the ratio of oxygen in water and hydrogen peroxide is 1:2. It is always in small whole number. So this analysis shows that the mass of one element that combined with the fixed mass of other element, that is hydrogen, is always in small ratio of small whole number. Now our fourth law is Gay-Lussac's law of gaseous volume. This was given by Gay-Lussac. This is the statement. When the gases combine or are produced in a chemical reaction, they do so in a simple ratio by volume, provided that gases are at same temperature and pressure. So simply this means the gases combine with simple ratio by volume. See here we have one volume of hydrogen and another volume of hydrogen. So there is two volume of hydrogen and one volume of oxygen is there. Friends, you should know that the volume is depends on the number of particles, number of molecules of gas. See, here 5 molecules are shown for one volume of hydrogen and 5 more molecules are shown for one volume of hydrogen. So according to this representation, there are 2 volumes of hydrogen that are represented by 10 molecules of hydrogen. Similarly, one volume of oxygen is represented by 5 molecules of oxygen. When these oxygen and hydrogen combines and form water vapor, so the volume of water vapor is 2 volume because the total molecules present in this box, the box of water vapor, are 10 molecules of water. So as you know that the volume of gas depends on the number of molecules. So there are 10 molecules. So according to our previous assumption, the volume of water vapor will be 2. Now we take another example. If we take 100 ml of hydrogen and combine it with 50 ml of oxygen, so how much ml of water vapor will be produced? Exactly, it is 100 ml of water vapor will be produced because the total molecules will be equal to the 100 ml of hydrogen. Okay, now our fifth law, that is Avogadro law. This was given by Amedeo Avogadro. It is stated as equal volumes of gases at same temperature and pressure should contain equal number of molecules. This is the statement, or this statement can also be written as 1 mole of each gas at standard temperature and pressure, that is STP, will have same molecule. Both of these statements says that the volume depends on the number of molecules. If molecules are same, then whatever the gas, it will occupy same volume. If volume is same, whatever the gas, the number of molecules are same. Okay, then one important thing is there, STP. What is STP? STP means standard temperature and pressure. So standard temperature and pressure 273.15 Kelvin, that is 0 degrees Celsius. This temperature and 1 bar pressure, that is exactly equal to 10⁵ Pascal. This temperature and pressure is taken as STP. Sometimes 0 degrees Celsius and 1 atmosphere is also taken as STP. Okay, so at STP, the volume of an ideal gas or a combination of ideal gases is 22.7 liter per mole. But if pressure is taken 1 atmosphere, this molar volume will be 22.4 liter per mole. So these are the 5 laws. Now, so we'll take one more example. See, if there is 1 mole of carbon dioxide at STP. Here STP will take 0 degree Celsius temperature and 1 atmospheric pressure. So the volume of 1 mole of CO2 at STP will be, yes, it is 22.4 liter. So what will be the volume of 1 mole oxygen at standard temperature and pressure? Yes, it is also 22.4 liter. This suggests that the number of particles in the carbon dioxide and the oxygen is same, so their volume is also same. It means the volume of gas depends on number of particles. You can say number of gas molecules. So if number of molecules are same, the volume will be same, provided that the temperature and pressure should remain same. Okay, so students, this example shows that 1 mole of carbon dioxide, 1 mole of oxygen, or you can take 1 mole of hydrogen at STP. The volume will always 22.4 liter, means volume does not depend on the nature of gas. It depends on the number of molecules of the gas. So how many molecules are there in 1 mole of gas? So these are 6.022 into 10 raised to power 23 molecules. This number is called Avogadro number, as you have already studied in your class 9. So students, these are 5 laws of chemical combinations. Thank you very much for watching this video lesson.